Hello, my name is Chris Fernandez. I am the SC Solutions Engineer for Keysight Technologies based in Nashua, New Hampshire. Today, I'm just going to show you how we go about um, doing a simple network emulator to filter and the modification of a packet. So to start off here, I have a simple scenario where I have two IP addresses, two IPv4 addresses, and I'm sending traffic according to my um, traffic definition here. So I'm sending actually 1,000 packets coming from uh, addresses based on what I did so far. So from here, which is 101.0.1, to addresses at 101.0.11 on the other side. The traffic is a simple IPv4 traffic. We can take a look at here for sake of completeness. I'm sending just IPv4 traffic, no other thing in there. The only modification I did was actually on the payload. So if you look at the payload here that I created a payload that has all zeros just for simplicity of how you look at this. And inside of the payload, I added this line here saying bad beef, ending with a 0. If you count the the offsets, that's what we use to filter this packet in Network Emulator 2, and that's how we modify it too. So I'm gonna just simply send that out so we can take a look at the packets that get captured on the other side, and we can take a look how this bad beef gets into the payload. So let me just move quickly here. I already was playing with this, so I have those two here. I'm gonna close this so we don't get confused. The traffic, in order for you to actually capture the data packet on port number 2 here, the traffic has to be applied. So let me just apply the traffic here before I can send it. If I skip that step, as soon as I start capturing and I apply the traffic, the data traffic gets disabled. Now that traffic is being applied, I'm going to capture it. So I'm going to start capturing. As soon as I can see that they start capturing, I can actually send the packets. So I'm just sending 1,000 packets. They're about 250 bytes long. It should take about 10 seconds for the packets to go across. And then we can take a look at the packets. And then from there, we can make a filter on top of Network Emulator 2 to identify the specific traffic that we are trying to modify. So as you can see here, traffic already stopped after 13 seconds. That means starting traffic, stopping traffic, and collecting statistics at the same time. So I'm going to stop my capture here, and I see I have 1,000 packets. So I'm going to double click on that. The packet captures will show up, and I have here, as you can see, I have from packets 1 to 10, sending from 11 to 20. And inside of this packets here, you can look at the payload. So I'm picking this particular stream here to differentiate between all the other ones. So it's the stream that's going from 101.0.2 to 101.0.12. And inside of this data, the payload that we modified, we can take a look at the payload. So the payload has, after the 45 here, this is where our IP header starts, right? And it has a bunch of stuff here that you can tell. This information here is what XA is using for traffic tracking, flow tracking. And all the way here in this byte here, which is starts 55 hops from the starting of the IP header. We can do it together, but starts from right here. So you count this here before the 45 as the 0, and then you can hop as many times for you to get all the way to bad beef here. This is how we actually going to go inside the packet, inspect the packet, and say, yes, this is the packet that I'm looking for. So from the layer 3 level, so from before the 45, we count 1, 2, and so on, all the way to over here, which is going to be 55. So I have to hop 55 times to get to this bad beef that's inside of my payload here. Now that I know the traffic that I want to modify, and I want to modify this bad beef here, and I want to, instead of bad beef, I want to say 0 through 7, right? So that's all the modifications that I'm trying to do. So now that I know what the traffic looks like, I can now pull in the modification for our network emulator too. So first things first, right? So first thing, we send the traffic and we capture, so we know exactly what we're trying to accomplish. For starters, we are going to do filter rules, meaning how we're going to classify this traffic that's going across. So if you look at the statistics here, this is one way for you to see that you are filtering on the correct packet. So let me clear all the stats profile here. So at this point here, I created already my profile here before I started presentation. So I know it's gonna work, but we can look at together under filter rules. So the first thing you gotta do is create a filter rule. I created a filter rule that has two conditions, and they have to be an and, meaning that this has to be true and this has to be true for this filter to take effect. In my case, what I was going to try to do is to modify this particular stream here with the bad beef to 0 through 7. So in order for me to capture exactly this stream here, I'm going to do a filter based on the IP address and on the bad beef inside of that packet. So those two filters, I'm going to enable them and I'm going to submit. At this point here, my filter should be working. I haven't done any impairment, so I haven't made any modifications here. So my two filters says, I want the destination to be 012, and I want you to look inside the packet, inside the payload, on the offset of 55 from the layer 3, and I want to mask all those bytes here, all those bits here, right, which is going to be 1 byte, and I'm going to look for bad beef inside of that. And if it matches, then I want to increase the statistics. So for the first step here, one thing that we do is actually look into the filters here and make sure that we're capturing the correct packet. To do that, we're going to go back into IX network and send another 1,000 packets, right? So let me send another packet. So 100 of them should be filtered out here. That means our filter is working for this particular profile. All the other packets should be going into the default, and we are not really looking to here. So I didn't reset here, but all the other packets are coming in here. So you should have 900 packets here and 100 packets inside of this profile that I created. So my filter is actually working. Now that my filter is working, I want to create an impairment. And the impairment is, I want to modify that. What I'm modifying is, as you can see here, I'm modifying it at the same spot as the bad beef is. And instead of bad beef, I'm using the values 1 through 3, 4, 7, right? And it's all a mask here. So I'm going to modify the bad beef into 0 through 7. And the mask is this. So what this offset here means 55. This is the byte offset, right? So this is how many hops we do on the packet. So let me pull in here so you guys can understand what this 55 is. So 55 is 55 hops away from where layer 3 starts, right? And then I'm going to modify the 7 here is think as the leftmost bit inside of that byte. I'm going to be modifying that particular bit plus 31 more bits. So I'm going to be modifying 4 bytes here, right? So it's going to be 32 bits total that I'm going to be modifying from the starting of my offset here. So I'm modifying 32 bits after I jump or hop 55 places. And this is the mask, meaning I'm going to match all of them. And the value that I'm going to be modifying is going to be from 0 through 7. So I'm going to make it easier here. Or I can do this and modify and put an 8 in there. So now I'm going to submit this modification, and then we're going to send traffic again. at this time. So I'm going to close this out. I'm going to go back in here. I don't have to reapply the traffic because I didn't actually modify it. I'm going to start capturing again, and I'm going to send traffic again. So let me do that. It's going to take about 10 seconds for traffic to run again, and another 1,000 packets will be collected. At this time here, the profile here, I don't know if I actually did reset. I did not. But you should see here that it used to be 6,500, now it's 7,400, so 900 packets got in here. You can see that now the cumulative is 200. I had 100, I didn't clear stats, so it's now 200. Those packets got through the filter, and I'm now stopping this capture and looking at what I got so far. So as you can see here, this first stream here, I did not modify that, right? Because it was not part of my filter. So the bad beef should be here. So bad beef, it's still here, right? As you can see right here. Now this is the stream that I modified, the one that had the 12 in there. So let me look at that. And exactly this is what happened, right? So I modified that. Now, instead of bad beef, you'll see 1, 2, 3, 4, 5, 6, 7, and 8. And it works. This packet is a valid packet because we did correct the packet, not just we modified, but we actually corrected the CRC afterwards. So the CRC at the very end, it's going to be correct, and it's a valid packet. But as you can see here, all the other packets are not modified with the bad beef. Only the one that is coming towards 10112. Anyway, this is all I wanted to show in this video. I don't want to make this a big video, but this is how you actually able to filter out based on a particular pattern inside your payload of your packet, and you actually modify that accordingly to using the network emulator 2. So the first step is to have a filter that does exactly that. Again, those two filters here are end. I can modify all of them if I, for example, if I take this out, all the packets destined to 101 and asterisks here, you can think as anything, will be catching, and this will be all the packets going to have modified. But if I want to have a specific stream, I can do it here or I can do it here. Either way, it should work. But this is the end, so both of them have to be true for this filter to take effect. Inside of the filter, what I'm doing, I'm impairing that particular field using those values that I already know because the filter worked. And the correction here that I'm doing is the correction. I can do all packets or only modify packets. It really, in my case here, it doesn't really matter because the modified packets are all the packets for this filter. And I'm correcting the CRC because we're making modifications to the packet. The CRC, the original CRC, will be corrupted and we're going to get a bad CRC if we don't click on this. The checksums here are not, doesn't really apply for us because we're not modifying any particular header. We're modifying whatever it's inside of the payload. And we're saying I wanted to modify every single packet that comes in. If I do one of the two, then only 50% of them are going to be modified. The other ones will not. So that to demonstrate that, I can do the 1 to 2, and then when I go back to statistics, I'm going to reset the profile here. I'm going to reset the profile for the default, and I can send traffic again. At this time, I'm going to do this, and I'm going to send traffic. And this time, what I'm expecting is that not all the packets for destined to 12 are going to be modified to bad beef. So as you can see here, the default profile now is completely empty because the bad beef profile here is actually capturing all the packets. That's because we modified the filter here to be more broad, and all the packets got inside of this filter here modified, right? So now when we look at what we capture, we're going to be looking at different packets being modified. So the first one here, I'm expecting that I'm gonna look inside of the bits here. So as you can see here, now if I'm looking at all those bytes here and you're looking at this particular byte here, you can see that some of them got modified, the other ones didn't, right? So it's usually 1 out of 2 packets got modified. So that's why you see this pattern here now, instead of being all of them. So anyway, this is all I wanted to show, how to use X Network Emulator 2 for you not just to filter out based on a packet payload, what's inside a packet, and also the impairment that we're using to modify that payload. I hope this helps. If you have any questions, of course, reach out to me. Thanks. Bye.